Hello, we are discussing about GATE 2014 ECE paper and the topic is related to digital circuits. In the following circuit employing pass transistor logic, all NMOS transistors are identical with a threshold voltage of 1 volt. Ignoring the body effect, the output voltages at P, Q and R are. So we are going to calculate voltage at P, voltage at Q, voltage at R. Okay, for the given this circuit. And we know that one NMOS transistor will be on whenever we are applying a plus 5 volts. That is nothing but plus 5 volts is going to be treated as logic 1, and you can say this is gate voltage. We can assume that one this is gate, and for NMOS transistor higher voltages is going to be treated as drain side. Drain is more positive than source, so this is drain and source for this one. And for this transistor it is gate and it is drain and this is source. For this last transistor this will be drain and it will be gate, this will be source. Okay, since the gate voltage for all the transistors, since gate voltage for all transistors is going to be 5 volts, Vg of all NMOS transistors is 5 volts, which is greater than Vt, which is nothing but 1 volt. Threshold voltage, Vt is nothing but threshold voltage, it was given as 1 volt. Threshold voltage is nothing but minimum amount of gate voltage that must apply so that a channel is established, so that the MOS transistor can act as on switch. Since the gate voltage is 5 volts, which is greater than 1 volt, so all NMOS transistors are in the on condition. Whenever they are in the on condition, at that time drain and source are going to be get shorted, so that we can think that one whatever the voltage you are applying at drain, that may be passed to source, because drain and source are going to be get short circuited whenever the transistor is in the on condition. By that time we can assume that one Vs is going to be always Vd, but there is a small condition to be known. Okay, so this is what the condition, this is very important. If the drain voltage is going to be less than Vg minus Vt, less than Vg minus Vt, then the source voltage follows the drain voltage. That is, whatever the drain voltage you apply, that will appear across the source if the drain voltage is less than Vg minus Vt. Else if Vd is going to be greater than or equal to Vg minus Vt, then Vs will be struck at Vgs minus Vt itself, because okay, this is Vs is going to be struck at Vg minus Vt itself. This is because we must maintain a threshold voltage gap between the gate and source such that it will be in the on condition. If it is going to be this case, if Vd is greater than Vg minus Vt, if let us assume source is following the drain, by that time Vgs is going to be less than Vt, which won't occur in the on condition. So on condition is nothing but the minimum voltage from gate to source is 1 volt. So to satisfy that condition, source voltage is struck at Vg minus Vt if the drain voltage is greater than or equal to Vg minus Vt. So based on these two rules, okay, based on these two rules we can get the voltages across P, Q and R. So look at the first transistor. Let us assume this is the first transistor. For the first transistor, drain voltage is at 5 volts and gate voltage is also at 5 volts. What will be the voltage at P? Okay, for that one, what will be the voltage at P is nothing but what is the source voltage of first transistor. So we must check the condition whether Vd is greater than or equal to Vg minus Vt, or this Vd is less than my Vg minus Vt. That you have to check. So Vd, first of all, Vd is going to be, Vd is 5 volts, Vg minus Vt, if you are going to say Vg is 5, Vt is 1, 4 volts. That implies nothing but this is the case of Vd greater than or equal to Vg minus Vt for the first transistor. So Vs will struck at Vg minus Vt, that implies nothing but 4 volts only. Even though you are applying drain voltage as 5 volts, it will stuck at 4 volts. So Vp is at 4 volts. Next, for the second transistor, if you are checking, for the second transistor VD is nothing but source voltage of first transistor, that is 4 volts. Okay, and VG is going to be 5 volts for all the things. So again you have to check what will be the value of VG minus VT. VG minus VT is nothing but 5 minus 1, which is nothing but 4 volts. 4 volts is nothing but, now Vg minus Vt is 4 volts, Vd is also 4 volts. This comes under the case as Vd is going to be greater than or equal to Vg minus Vt. So again the source voltage is going to be stuck at Vg minus Vt. So that implies nothing but again it is 4 volts. So this is again the Q is going to be is at 4 volts. Next, now source voltage for the last transistor, that is third transistor. This is same as the second case. Since the drain voltage is at 4 volts, gate voltage at 5 volts, Vg minus Vt is nothing but 4 volts, which is equal to the drain voltage. So this comes under the second case. By that time Vs must be equal to Vg minus Vt. Again it is 4 volts. So the voltages at P, Q and R are going to be 4 volts. 4 volts, 4 volts, 4 volts are going to be the answer. So the right option for this question is C. 4 volts, 4 volts and 4 volts. Thank you.